Hello, everybody. So let's talk about Flutter. So these slides are on slides.today. You can visit them also tomorrow, although that TLD doesn't exist yet. Google, if you want to sponsor some more things, I'll buy another domain. So I'm Abraham. I have a large beard, in case you didn't notice. I try to make these talks accessible for people who may not be able to see it, so I like to say it out loud. I'm a Google developer expert. I specialize primarily in web technology and Angular, as well as a couple of other smaller things. But those are kind of the main things that are relevant to this. So I have a large number of years building websites, and recently I've been doing a lot of Flutter development as well. So I'm from Wisconsin. This is a photo I took on Wednesday when we were in the middle of getting 10 inches of snow. So I know that at this time of year, San Francisco people like to complain about the cold, but it could be much worse. I lived in San Francisco for a few years back, so I'm familiar with the area. I work at a company called Bendyworks. We're a small consulting shop. We do a lot of Ruby on Rails, a lot of various JavaScript things. And one of the things that we have at Bendyworks is we have a vision statement that is share joy and success in our craft. And this vision that we have allows me to spend time coming to events like this, learning new technologies. But I also think that it fits really well with Flutter in general. And I'm going to explain a little bit how. So Flutter lets you build expressive, beautiful UIs. So those really let your users have a joy in using your app. Like using an ugly app it's terrible. So Flutter lets you have a nice, beautiful UI. But beyond that, when you're building it, it provides a joyful development experience. One of the ways it does that, is, for example, is stateful hot reloads. We'll talk a little bit more about that later. But it also is not just about like the little things, but Flutter kind of gets out of the way and lets you build the app that your users are going to use and enjoy. So that's one of the reasons that I like Flutter. And then, of course, it's got native performance. So, I'm sure as web developers, there are some other really good frameworks that give you really good developer experiences, but don't have quite that good of a user experience once you ship it to the device. And Flutter is a really good end result when you ship it to your users as well. So Flutter, cross-platform mobile apps. You can write them in one code base, but actually, Flutter runs in some places that you might not think. This is Flutter app. This is a Flutter app running on a Raspberry Pi, which is pretty cool. There's some work being done running Flutter on desktop apps, so Linux, Windows, Mac OS. I don't think it actually runs on typewriters, but that would be pretty cool if it did. Maybe if your typewriter is a Raspberry Pi, then it would. And then in December, Google at their Flutter Live event actually demonstrated running Flutter on the web using an experimental tech preview called Hummingbird. I'm not really going to talk about that right now because not a lot is known, so whatever I say now is probably going to be wrong once it actually comes out. But eventually, it's actually just cross-platform apps that you have one code base that will run just about anywhere. And the engine that powers Flutter is the language Dart. This is a language that Google started developing a little while ago. It didn't take off for a while. It's having a renaissance now with Flutter, and it's actually pretty neat. Dart feels very familiar to a lot of people from a lot of different language experiences and language backgrounds. So I want to talk a little bit about how right now. So being at a web meetup, an HTML5 meetup, I expect some of you have some experience with JavaScript. JavaScript runs on a single thread with an event loop, and Dart does too. So you've got that in common. If you actually, if you're interested in learning more about event loops, Jake Archibald has a fantastic video about event loops that's phenomenal. But also just-in-time compilation, just like JavaScript. So, in your development lifecycle, it's very quick to just run some code, get it going. But something that's kind of a little different is that Dart also supports ahead-of-time compilation. So this makes it so that once you want to, you have your app dialed in and you want to ship it to your users, it's fast and performant and optimized for the end device, which is really sweet. It's type safe, so hopefully some of you are writing type safe code with TypeScript. If you're not, I highly recommend it. TypeScript is fantastic. So I would like to do a little comparison of how Dart can compare to TypeScript. Anytime I'm starting a new web app nowadays, I always choose TypeScript. So TypeScript, we're going to have a little class. Pizza, because who doesn't like pizza? So then we're going to give a property on this pizza class, how many slices are in that piece of pizza, or that, how many slices for the entire pizza. So you'll notice here that it's slices, we're going to say it's a type number, so if you try to apply a string to it, it'll fail, it'll say, no, you can't do this. We'll give it a constructor. The constructor will take a parameter of the toppings that you want to put on the pizza. In this case, you might want to put multiple different toppings on a single pizza, so we're going to say it's an array of strings. And then baking it will take a little while, so we're going to take an asynchronous function. This is, it doesn't actually take, it takes much longer than 5 seconds to cook a pizza. I don't recommend you eat a pizza cooked in 5 seconds. This is for artistic purposes, I guess you could say. But essentially, when you call the bake function, it'll wait 5 seconds and then say, okay, you've been baked, you can now eat this pizza. So that's a bit of delayed code you can get. And this promise set timeout, you don't have to worry about that too much. It's just an artificial delay. And then you have to call that code somehow. So in this example, we're going to take an arbitrarily named function called main, and we'll make it asynchronous so that we can use await in there. If you're not using async await, that's something else you should go check out. So now we can instantiate a pizza. And I hear that pineapple is a controversial topping, so I went with that. We can talk later about Vim versus Emacs if you want. So dinner will inherently have the type of pizza. We don't have to explicitly do it. We actually didn't explicitly have to label slices as a number earlier, but TypeScript is smart enough to just kind of know that. So once you've defined what your pizza is, you can await for it to bake. And once it's done baking, you just console log, yum, I had a pizza, and it had these toppings on it. And so that will do a nice little bit of JavaScript string interpolation. So that's some overly simplistic TypeScript, but it highlights a number of different features of TypeScript. And hopefully this is familiar to most of you. So let's look at how we would do this with Dart. So it actually starts out exactly the same. You've got a class pizza. This is slightly different. So now the types are different. So it's int instead of number. It's a list instead of an array. And the types go in front of the identifiers. But overall, it's actually like you're conveying the same stuff. It's just slightly different. The next thing that's a little different is the constructor is the same, uses the same name as the class. This actually leads to a really neat feature I like about Dart that I'm not going to talk about tonight, but it's called named constructors. So you can actually give a class like 5 different constructors. And so you can have like a constructor that consumes JSON, a constructor that consumes a string. It's super neat. Async is supported. It's after it, except so that types are before it, but async is after it. Don't worry about it too much. And then there's a little bit of other difference here is that instead of a promise, you have futures. And a future feature, a current future feature is delayed. So that's a little bit of a nicer developer API than doing a set timeout. And then Dart has this nice little duration where you can give it milliseconds or seconds or whatever. So now we have to call it. With Dart, you define a main, and when that, that's the default function that will run within your file. So we'll make this asynchronous. And then this is very similar, except there's no new keyword. And that's because in Dart 2, new is optional. In Flutter, you tend to instantiate tons and tons of instances, so you won't see new that often because it's very verbose. You wait for it to bake. And then you have a print instead of a console log. And the string interpolation is slightly different. But you might think, this all looks fairly familiar. Like, those 2 examples were pretty similar. So that's a good look at, as long as they're both static, they're both type safe. So as you're writing them, your compiler will tell you, you're not doing this right. So as you don't have to ship it to the user and figure out later that you screwed up. It'll tell you right in the editor, so that's super nice. All right, let's talk a little bit about Flutter now, because that's, other than the wine, that's why you're here, right? So Flutter, one thing that's kind of neat, everything's a widget. So I want to talk a little bit about what a widget is. And actually, coming from the web, a widget felt really natural to me. This is a very simplistic Flutter widget. Basically, you're going to extend a stateful widget. So this is just a simple hello world widget. All it does is when it's executed, it'll return the text that says hello world. It's not particularly useful in a real world scenario, but this is the core building block that most code you write will be based off of. And some other things that look very similar to it. Web components. Who here has written a web component? Okay, a few people. Excellent. Web components are fantastic. It's a very similar concept. You create an HTML element. When it's connected or inserted into the DOM, then it'll just write to the inner HTML with that same text. So these are basically the same thing. Or if you're coming from a React background, this is what it looks like in React. Pretty simple. So if you're doing web components, this is how you would end up displaying it on a page. You would have, you would define your own custom app header in your app toolbar. And these are components that behave very similar to widgets in Flutter. In a Flutter alternative would look something kind of like this. Instead of doing HTML markup, you're just instantiating those classes directly. And those two aren't actually translations of each other, they're just very similar. But coming from web, I've had a couple of gotchas that surprised me and took me a little bit to wrap my head around. One of them is there's no templates in Flutter. Instead, you just instantiate a bunch of objects, which is fine. It takes a little getting used to. It ends up, you have a lot of nested parentheses, but you can architect your code so that it's not so bad. And there's no CSS. Normally, you want to add some padding to something, so you define a class, define that CSS, and put the class on an element. In Flutter, you use a widget for this. So there's a padding widget. And you can say, this is how much padding it should have. There are a number of other ways to add padding. So you could have a container container is very similar to a div. You can just kind of put shapes on it and stuff. But you can also do some really advanced widgets. So example is a gesture detector. This one's just looking for a tap, but you can say, hey, anytime somebody swipes this, those side swipe menus where you swipe from the edge, you just implement that with a widget. But you can also have more complex things that are widgets. So if you're a Redux fan, you want to have your store. This is not displayed at all. This is not represented at all in the UI. But this will affect all of the children and how they are displayed in the UI. So your widgets are not always UI. A lot of them are, but some of them control how your app behaves. So Flutter widgets, very React-like. One of the ways that they do that is with stateful widgets. So we talked a little bit about stateless widgets earlier. A stateful widget will look very similar if you're coming from React. You basically, one of the kind of neat things about it is you have your widget, which is on one side, and then you have your state, which is another little object over here. So they're kind of separated. And if you're coming from React, set state is going to look very familiar. And then one of the neat things is that since the widget and the state are separated, the state can be long-lived. And anytime state changes, you can tear down and rebuild your widgets, and the state, because it's separated, Flutter is like, cool, I can just leave that there and tear down all this other stuff. So the widgets get reborn with super cute kittens. And this one makes Flutter super fast because it doesn't have to do interweaving of a bunch of state and UI and figuring out what needs to be rendered and what needs to be reset and all that stuff. But this also is what makes it so that stateful hot reload is possible. So you can have your state that's kind of over here on the side, and your entire UI can be rewritten, and all of that state doesn't change. And as the UI is changing, your app looks completely different, but that state is still there. It's super, super good developer experience. So it's reactive. That's set state we looked at earlier, but there's also much more advanced approaches. Flutter has built-in stream support if you want to do that, but there's also RxDart. There's Redux, or just about any other kind of pattern you want to do. And because of this kind of reactive state handled off to the side, and being super fast at rebuilding widgets, this actually makes Flutter really good at some things that are super hard on the web. I don't know how much animation people have done, but trying to take an element here on one page and animate it into an element on a different page, it's really hard. It's very easy to get into some performance pitfalls that'll make it render very, you'll hear jank a lot of times as a term used, and that's things stuttering. Flutter is really good about this. I wrote a sample app that uses a built-in widget called a hero animation. And it's basically like if you have two different pages and you have the same image on both of them, or even different images, you can just wrap both of them in a widget, and Flutter will just automatically handle doing a beautiful animation between them. It's super easy. But you can also do more advanced kind of custom animations and tweening if you want. It's pretty, this is a 0 to 1 with Flutter is a good blog post talking about animation. So testing is something I mentioned that Bendyworks does a lot of Rails stuff. So testing is one of the big mantras of Rails. So coming to Flutter, I was really interested in what the testing frameworks looked like. And it's actually pretty good. There's basically 3 different layers of testing that you can work with. The base layer is unit testing. This is the fastest. This is actually just Dart. You're just writing Dart tests, basically. And so you can, have a class and say, hey, this class should handle this input this way and return this thing and do this calculation. And it's very fast and very easy to use. Kind of the next level up is widget testing. So with widget testing, you're doing a little bit more work. If you're coming from Angular or React, it's more like component testing, where you have your form, and you test to make sure that it has error states at the correct input, and it's more encapsulated but does more work. This is provided by Flutter with a Flutter test package. It takes a little more work to set up and is a little bit slower, but it also is very important. One of the things you have to do with it is you have to tell the testing framework to build up the widgets and render them and run the tests on those. And then the next kind of third level is integration tests or feature tests or end-to-end tests. These are generally run on an actual device or maybe an emulator. And so you can actually have an Android one and an iOS one and get a lot of really good assurances that your app runs on those devices. So you could have I don't know what I think Jelly Bean is pretty old now, but you could have a Jelly Bean device that you run your tests on to see how your app runs on that. And these are the slowest, but this is something like, okay, I want to make sure that when a user fills out this form, or like a user can get to this page, fill out this form, submit it, go back to the main page, and the content they just created is there. So you can test full feature flows and have a really good confidence that your app will at least work. This is a really important test. I found in my experience with Flutter is that a lot of tutorials, a lot of samples don't include testing. I think more people should do testing, so if you have questions about it, please reach out to me. I will help you write more tests that are good. So where to start? I'm going to give you a couple of guides and a couple of links of where to get started, and then I'm going to do a quick little demo that hopefully will work. I had some dependencies this afternoon that were a little weird, so we'll see if it worked. We'll see if the demo deities are with us today. The first thing is, so for the month of December, I wrote a blog post every day on building a Flutter app. It's a huge amount of work. I don't actually recommend writing a blog post a day. But it's also really rewarding. And so one of my goals with this month of Flutter was that I wanted to give people a look at what it was like to build a full application with tests, with CI, with linting. And there's the issue tracker is open, so you can just go look at it and see as I was progressing through it. I'm going to be continuing this series soon, so if you want to follow along, you can go to bendyworks.com/blog. And eventually I'll get to the point where I'm actually publishing it to the app stores and walking you through how to do that. There's actually a couple of good services out there that work with auto-publishing. So like, you write some code, put a test on it, push it to like GitHub or something. The tests run. Once the tests run, you merge it. This service will then take that, build it, and push it to your test users. So you can ship apps very quickly, almost as fast as websites, but not quite. Flutter has some great code labs. I highly recommend you check those out. They're a little bit smaller, but give you a good look at a bunch of different approaches and different important integrations. Flutter by Example is another great site. They have a fairly complex apps, and they're very useful. And then Awesome Flutter is kind of the last thing that I would recommend. And this is just basically a huge list of awesome Flutter. Oh, and then there's one other thing. Next week, I will be launching flutter.directory, which is going to be a categorized collection of Flutter articles. So like, you want to know how to use a widget, or you want to know how to test something, this will be a huge collection of very good, high-quality articles specifically for what you're looking for. So you can follow me on Twitter, and I will be announcing it next week. Or I'm announcing it now, but I will be launching it next week. Yeah, I'll announce it again. That's fine. I can do that. OK, so let's do a little bit of quick coding. And we'll see if we can how much of this we can fit on the screen. OK, so on the left, I have to. The left-right tool doesn't work when it's in the wrong direction. So I'm using VS Code. I used Android Studio for a while, but coming from web, I used Atom for a long time, and Atom and VS Code are a lot more kind of minimalist and lightweight than Android Studio, so I couldn't get into Android Studio. But VS Code is a really good editor and has some pretty good integrations. One of them is, so for me, Control-Shift-P will bring up this kind of like inbuilt CLI-ish type thing. It has a bunch of commands. So there's one command, launch emulator, that'll launch the emulator that's on the left, or actually your right. But then there's another one, debug, start debugging. So I run this, and Flutter will say, hey, let's build the app, push it to the emulator. The first time you do it, it'll be slightly slower because it has to do more work. But then as you change stuff, it'll start going much quicker. So this is basically the default generated Flutter app, which is run by using the command line. You just do flutter create the name of the app, and it'll pre-build this app. There's basically one change that I made where I took a Firebase dependency and added that. I haven't done anything with it yet, but I've added the dependency because you have to edit a bunch of weird files to get it to work. And I'll hide that sidebar. So this title, we can do SF HTML5. So I'll hit save, and then the title is already changed. So it's very, very much like, a web app live reload. But one of the nice things, so I will take this button, and you click it. It's basically a, does anybody play cookie clicker? This is basically a minimalist cookie clicker. So you tap stuff, and it counts how many times you've tapped. But then we can go in and say, let's go with, I think we can do debug show checked mode banner will remove the debug banner up in the right corner. So now that's gone, but the count is still there. That's the stateful part. The state of how many times I've clicked has stuck around. Let's see. So this blue bar across the top, that's an app bar. That's a built-in widget that is part of the material package. The blue is very common, so I think maybe we'll give it a different background. Make it white. Well, now the text is gone, so we're going to have to fix that. There are more advanced theming approaches than what I'm doing here, but this is just kind of a quick, like, hey, cool, I can change some colors. So this text widget can do I think it's a text, not text, font, style, which is a text style. And that will take a color, and we can do colors.black, and then save it, and now that's fixed. We could do some things like, let's see, outside here we could do, well, oops. No, I don't need the S. We'll center the title then just moves. And then there's also, we could do elevation 0. We changed a little bit of a theme. Okay, so what I actually wanted to show for here, so there's a package called Cloud Store, which works with the Firebase's Cloud Store. So I've already done the install steps. I'm going to copy their little base example here. We'll throw it into the editor. Before I change this to update it and implement it, oh yeah, we need to actually import the Firestore. So on Linux and Windows, there's a control period that'll bring up this little, oh wait, I didn't actually find it. Maybe I have not actually pulled in all the dependencies. No, I do. I have it. Okay. Well, usually, a lot of times you can select something and then just auto-import it. I've noticed sometimes it doesn't always work. That's fine. We'll import it manually. So import package, Cloud Firestore. It's Cloud Firestore, Cloud Firestore. Well, the demo is mostly working. So at least it builds now. This book list is not being used because it's not actually, we don't actually want to use a book list. So I have this little Firestore database. I don't need that. Okay, so there is this little website. So if you all want to pull out your phone and go to sfhtml, oh no, I forgot the 5. Shoot. All right, well, we'll have to forget HTML5 for a little while and just do plain old sfhtml-flutter-demo.firebaseapp.com. And so if you go there, you'll find these 4 buttons. Is anybody familiar with what a boop is? A boop is, so you have like a kitten and you tap its nose, that's a boop. A blep is a kitten with its tongue stuck out just a little bit. I'm not actually sure what a doot is. I just was like, that sounds cute. And a mlem is the sound the blep makes as it's happening. So if you go to this site and you start tapping on the buttons, data should start showing up here. If it's working correctly. Yeah. So there's lots of boops and bleps and mlems all coming into the database. All right, so now we know that there's some data. So we know it's not a book list anymore. Now it's going to be a boop list. It doesn't come from the books collection. It comes from the boops collection. And then, so there is so if we look at one of these documents, there's a date and a type. So the type will just be which button you tapped. And keep in mind that this is not, you don't actually want to let just anybody write to your database, but for demo reasons, I did lock it down so that you can only submit those 2 fields, and you can only submit those 4 values for that other field. And the other field the timestamp has to be the current timestamp. So it is pretty locked down. Okay, so now we've got a boop list. It's not actually displaying anything yet, but we can come in here. So this column is currently displaying the text, the counter, and that's it. And we can actually just remove that and do a boop list. And now we have that data getting fed in from the Firestore database. But that doesn't look very good. So let's do, maybe instead of a tile list, we'll do something like, there's a card. This gets a child. We'll do text. It's a document type. So we save that. We talked about how to do padding, so we should probably do some padding. I think their card probably has a better way of doing this, but we'll wrap this in add padding. Padding is pretty neat. There's a couple of different things you can do. You can do symmetric, so we'll do vertical, we'll say 24, and then you can do horizontal, we'll do 16. Yes. So there's now a little bit more space. And then I think card can probably also do a color. Oop. So that's red, but what we could do is instead we'll do color, and we'll do document type. So then that isn't defined yet, but we can create a method. Oh, that is not what I expected. Okay, there we go. So this will do something like if, oh, we don't want document, we want type. Okay, so that gets a type. And this would be a string type. So we could do something like if type is equal to blep, we'll do return colors red, else, return, colors, blue. Why not? We'll do blue. And now you got a couple of different colors. And if you keep tapping them, you should see them streaming in live.
Can you say something about the list scrolling, paging?
Yeah, this is using a where is it? A list view, which is a built-in widget that is a virtual list. So it should performantly render what is needed for the current view. Maybe this list view might not be the smart virtual list. I know there is a virtual list. I forget if it's this particular widget or not. All right, cool. So that was a quick little live demo. And thank you very much.